Question 14, we have f of x is equal to 2 times 3 to the x minus 2 minus 1. Okay, the first thing I'm going to do is graph or come up with some points based off of this part of the graph, and then I'll adjust it or translate it based on the negative 2 and the negative 1. So I'm going to take 2 and I'm going to take negative 1, plug it in for x, so I get 2 times 3 to the negative 1, so I'd end up with 2 over 3. So I end up with 2/3 here. Then for the second part, I have 2 times 3 to the 0 power, so I end up with 2 times 1, or 2 there. And then finally for this, I end up with 6. Alright, now remember we're going to adjust it. This moves our graph down. So I'm going to subtract 1 from each one of our f of x or y values right here. Okay, now, so for this one, this right here is going to move it to the right. Okay, this is going to move it to the right, so I'm going to add 2 to each one of the x values. Okay, so then we end up with x, so we're going to end up with 2. I'm sorry, that's going to be 1, because then I'm going to end up with 2 and 3, and then here I'm going to have negative 2/3 minus 1/3, so that's going to be negative 1/3. Okay, because that's going to be 2/3. You get the same denominator. Put that over 1, so you get 2/3 minus 3 over 3. That's going to be the negative 1/3. That's where that's coming from. Then I got 2 minus 1 gives me 1. 6 minus 1 gives me the 5. Okay, so now let's go over here and draw us a graph. And now looking at it, we know that this is a growth factor, so we're going to have an exponential growth. Okay. Now, always, now on this, this is on your paper. All right, so I'm going to draw in the asymptote. Asymptote is going to be a negative 1. All right, and so that's going to help us. Our graph has been translated or shifted down. So we had a vertical shift of negative 1. Alright, and so I'm going to start plotting points now. So when I'm at positive 1, I'm down at actually a negative 1/3. So I'm somewhere in here. Okay, then when I'm at 2, I'm up at 1. And then when I'm at 3, I'm all the way I'm up here. Alright, and so our graph will get closer and closer to negative 1. Won't actually cross it. And then this one goes up like this. And so we have a rough idea what our graph should look like, okay, based on the different things that we just graphed. Now our domain here, okay, which is the A part of the question. Domain is all real numbers. X can be anything. And then the range here, okay, we're going to get closer and closer to negative 1 but never cross it. So our range y is greater than negative 1, and again it could have been written negative 1 to infinity like this. Either way is acceptable. Alright, then the B part. Now the B part of this is as for increasing or decreasing. Our graph is constantly increasing, so we would say from negative infinity to positive infinity. Our graph, as x goes from negative infinity to positive infinity. So we'll write it the same way, so the notation is the same. We're increasing. And just think about it, it's a growth problem, so it should be increasing. Alright, now the C part. We're going to have to do some calculations. Because they want us to come up with the rate of change when we're from negative 1 to 1. Alright, so we have 1. So I'm going to use that as my x2 and y2. So we already have that. Now let's see what happens when this is negative 1. So going back to our original function, we have 2 times 3 to the x minus 2 minus 1. So we're going to plug in negative 1 to come up with what the f of x is when it's negative 1. So let's go 2 times 3 to the negative 1. Alright, minus 2 okay, minus 1. Alright, so for this one we end up with 2 times 3 to the negative 3 minus 1. Alright, so we end up with 2, and then we have 3 on the bottom, 3 to the third minus 1. Well, 3 times 3 is 9, times 3 is 27, so we end up with 2 over 27 minus 1. So let's go ahead and we're going to convert that to a decimal. So we end up with 2 divided by 27 minus 1. We end up with negative, I'm going to do 3 decimal places, negative 9.26 as our y value. Alright, so to come up with the rate of change, it's going to be y2 minus y1 over x2 minus x1. Alright, so we have the x2 and the y2 listed. So it's going to be negative 1/3. Now if you want to convert this to decimal, it would be 0.33. Divide the top by the bottom. Alright, subtract it from y1, which we found to be negative 0.926 over x2, which we found to be, we're going to use as 1, and we said x1 was negative 1. So minus negative 1. So it's going to be over 2. So we're going to take 1/3 and subtract. Actually, we're going to end up adding. So let's go ahead and get rid of some of these signs. So that's plus, 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 plus. So let's combine that. So we end up with 1/3 and divide that by 2. We should end up with we're going to round, so we round to 1 decimal place. We end up with 0.3. Now this is rounded, so 0.3 would be our rate of change. And again, if you wanted to, go ahead and convert that to a decimal. And anyway, by the time you end up through all this, you end up with 0.3. Okay, it's actually negative 0.29. Well, not negative, but because you have the double negatives. But you should end up with positive 0.29. All right, and you end up, this is your final answer. All right, and then finally the D part, which is the end behavior. All right, let's go back up here and look at our graph. All right, talking about end behavior. As x is going this way, so as x is going to positive infinity, y is going up too. So y goes to positive infinity as well. Now, as x goes this way, y is getting smaller, but it's not going to cross negative 1. So as x goes to, now the notation down here will say as x goes to negative infinity, okay, y is approaching the asymptote, which the asymptote in this case was negative 1. So y goes to negative 1, and as x goes to positive infinity, y goes to positive infinity. So that would be our end behavior.